Now based on the rules that we have just proven earlier, we can even see this. Check this one. Let us say probability of an event A is given as 1 by 2, probability of an event B is given as 1 by 3, and probability of an event C is given as 1 by 4. And if it is given that all these three events are independent, then they will ask you some questions like this. What is the probability of the event that A union B complement intersection C will happen, right? Or they will give you some question like this: is A complement union B union C complement, what is the probability of this? Or they will give you some question like this: what is the probability that A complement intersection B complement intersection C complement will happen? Now in order to answer these questions, you should know certain formulas like this. See, one thing is, if A, B and C are independent, you can prove that A union B complement and C, these two events are independent, right? We have earlier proven that A union B and C are independent, but you can still prove that A union B complement and C are independent. Also you can prove this one also, right? A complement union B complement and C, these two events are also independent, right? So now knowing such things will help you in answering these questions easily. So the reason is, see this, now if you want to find out the probability of this event P of this, right? So how are you going to write this? This one is nothing but two events. Now you know that these two events are independent and now there is an intersection between them. So how can you solve it? Just the multiplication rule, right? So P of A union B complement into P of C, and we know about this P of A union B complement. So what is P of A union B? It is straightforward: P of A plus P of B complement minus intersection of these two, P of A intersection B complement. Now P of A intersection B complement, since we know that A and B complement are already independent. Why? If A and B are independent, then A and B complement will also be independent. Now here we have to write P of A intersection B complement. We know that it is nothing but P of A into P of B complement. So when you are writing this intersection formulas, knowing that they are independent will be helpful. And finally multiply it with P of C. Got it? And similarly here we are having union, right? So we know that when you have union of three events, then you can write like this: P of this one is nothing but P of A complement plus P of B plus P of C complement minus, you have to take two events each, P of A complement intersection B minus P of B intersection C complement minus P of A intersection C complement plus P of A complement intersection B intersection C complement. Now these three probabilities are given, but in order to derive these four probabilities, you should know that all the events are independent. Since A and B are independent, A complement and B are independent. Since B and C are independent, B and C complement are independent. Since A and C are independent, A and C complement are independent. Since A, B, C are independent, A complement, B and C complement are independent. Therefore, you can evaluate it by taking the multiplication rule, right? And now check this one. If you want to find out the probability of this, how can you do that? Same way. Since A, B, C are independent, A complement, B complement and C complement will also be independent. And since it is intersection, you have to just take the product, which means P of A complement into P of B complement into P of C complement, right? And how can you answer this one? Same way. This is an event and this is an event. Since A, B, C are independent, we can prove that A complement union B complement and C, these two events will also be independent, and we can expand it the same way. How? If you want to find the probability, you have to apply the multiplication rule because these two events are independent, which means P of A complement union B complement into P of C. Now what is it? Now you have to evaluate P of A complement union B complement, which is nothing but P of A complement plus P of B complement minus P of A complement intersection B complement. Since A and B are independent, we know that A complement and B complement are also independent. Therefore, I can apply the product rule here. What is it? P of A complement intersection B complement is equal to P of A complement into B complement. Now you multiply with P of C. So any questions they might ask like that, you can just apply this rule and find it out. Okay, and there are one important interesting property here. Let us say A and B are two events which are mutually exclusive. Mutually exclusive means if you have the sample space, then A and B, there will be no intersection, which means if A happens, then B will not happen, and if B happens, then A will not happen. Got it? Now if they are mutually exclusive, then what can you say about this independence? Are they independent or dependent events? Let's try to find out. P of A intersection B, if it happens that P of A intersection B is equal to P of A into P of B, then we can say that these two events are independent. Now let's see this. In case of mutually exclusive events, there will be nothing in intersection, right? So P of A intersection B is going to be 0, which means left hand side is clearly going to be 0, but then right hand side will never be 0 because there is the probability for A is some positive number and probability for B is some positive number, because they are definitely going to happen, isn't it? Right? And now the product is never going to be 0. Therefore, if A and B are mutually exclusive events, then A and B will be dependent events, because this formula is not satisfied. It is very important rule. Remember that if A and B are mutually exclusive, then they are dependent events. Why are they dependent? Because happening of A is depending on B and happening of B is depending on A. Why? If A happens, then B will not happen. If B happens, then A will not happen. That is how you can check it. Okay. Even though these two concepts are different in some sense, because mutual exclusiveness is related to set theory and independent events related to probability, but we can somehow combine them and get this result, right, from this formula. And also you can also derive this one. See this, if you have an event A and if the probability of A is 1, which means it is very certain that A will happen, definitely happen, then A is independent of any event B. Why? See this. Now P of A intersection B, if you try to find out, that will be P of A into P of B, right? That will simply be P of B, isn't it? Now what will be this P of A intersection B? Now since A is definitely possible, it must definitely be sample space, right? And then B must be something here. Therefore P of A intersection B will be equal to P of B itself. And also we got that it is equal to P of B. See, what do you mean by P of A equal to 1? A is the sample space. Sample space is the only event which is going to have the probability of 1, isn't it? When you are conducting the experiment, P of A equal to 1 is, P of S equal to 1. By saying that, what we really mean is one of the possible outcomes is definitely going to come out. That one anyone can say with 100% probability, isn't it? When you are flipping a coin, what is the probability that you will get either head or tails? 100%, which means 1, right? So if you take the entire sample space, the sample space is independent of any other event, because I don't care what event happens, always sample space happens, which means it is independent, isn't it? Similarly, you can also prove that if P of A is an event with probability 0, if A is an event with probability 0, which means if A is never possible, right, then A is independent of any other event. Why? If A is never possible, which means P of A intersection B, you can verify this formula, equal to P of A into P of B. Now, A is never possible, then what is the intersection with B? It will never be possible, right? Which means if A happening is not, if A itself is never going to happen, what is the probability that A and B will happen? Never, which means it is 0. And already we know that P of A is 0, therefore 0 multiplied with anything here you write, it is going to be 0. Therefore this property is again satisfied. And so if P of A is equal to 0, then A is independent of any event. So, and similarly if P of A equal to 1, it is independent of any event. You can remember them. Okay. So this is how we can apply the independence formula in order to solve various questions. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.